Formation of solid Earth. When Earth first formed, it was very hot. Three sources of energy contributed to the high temperatures on the new planet. First, much of the energy was produced when the planetesimals that formed the planet collided with each other. Second, the increasing weight of Earth's outer layers compressed the inner layers, which generated more energy. Third, radioactive materials that emit high-energy particles were very abundant when Earth formed. When surrounding rocks absorbed these particles, the energy of the particles' motion led to higher temperatures. Early solid Earth. Young Earth was hot enough to melt iron, the most common of the existing heavy elements. As Earth developed, denser materials, such as molten iron, sank to its center, and less dense materials were forced to the outer layers. This process is called differentiation. Differentiation caused Earth to form three distinct layers. At the center is a dense core that is composed mostly of iron and nickel. Around the core is the very thick layer of iron and magnesium-rich rock called the mantle. The outermost layer of Earth is a thick crust of less dense, silica-rich rock. Today, processes that shape Earth, such as plate tectonics, are driven by heat transfer and differences in density. Present solid Earth. Eventually, Earth's surface cooled enough for solid rock to form. The solid rock at Earth's surface formed from less dense elements that were pushed toward the surface during differentiation. Earth's surface continued to change as a result of the heat in Earth's interior, as well as through impacts and through interactions with the newly forming atmosphere.